Welcome to the secure coding lesson. We'll be going through different labs today, but we'll go through an introduction first in this topic about secure coding. So this is a part of application security, and there are different types of applications that we're referring to. One of them is the code itself. So the scripts or the code, it could be C++, it could be Python, it could be any kind of programming or scripting language. And this topic is about the security of the actual code itself. So there is a separate topic on web application where there is application security for web applications like your uh, front-facing web service that contain databases and stuff like that, like the shopping sites or something like that. But this is the actual coding itself. So we'll go through that, and then later on we'll go through some of the labs as well. There should be about 5 or 6 that we'll go through today. So what is insecure? What is an insecure application? Um, we'll go through that, and I'll show you a real demonstration that you can practice on your own as well. But we'll definitely go through that. But the secure coding and application security is broken up into 2 main sections. The first one, which we'll be going over in this lesson, is coding, programming, and applications. And the other part is a web-based application. There will be other videos on that a little bit later on. So before we go into that, what is the big deal with insecure coding? What is the big deal? What's the issue here? And what can we do to fix this? We'll go along. We'll talk about that in the next couple of slides. So what's the big deal? Why is so important? If an attacker can find a flaw in a code or an application itself, or the code somehow, then they get direct access to the CPU, the RAM, the storage, and the network interface. If a hacker or a bad actor or there's so many different terms. We'll just say hacker for now. Not all hackers are bad, remember, but just for now we'll just say hackers. If they're able to break into the code somehow, they can inject some other code, or they could put in their own little coding inside it. Then they get access straight to the hardware, which means that they can they can attack other parts of the system very, very easily. If they can get access to the CPU, RAM, storage, network interface through our application, they can cause all kind of havoc. So that's really bad for us as normal everyday users. Also, we need to protect our private data. Again, if hackers or bad actors, or if they find a way to break our code, coding as in our programming code, they can also find ways to the data that's supposed to be encrypted, supposed to be hidden. That's also not great. Also, we want to protect our business continuity. For example, there could be, if the coding is not secure, there could be something where something like a buffer overflow, which we'll talk about later, which can actually cause our system to shut down, and our business won't be able to operate because of this buffer overflow will stop our whole system from working, or it will actually shut the operating system down, depending how severe it is. There's also compliance and regulation. Sometimes we actually just have to secure coding according to some government or some sort of compliance regulation. But in the end, we're protecting our users as well. This is the most important thing. That's the big deal about secure coding. So what are some vulnerabilities? Well, um, insecure data storage. If we don't encrypt our data in storage and hackers can break our code somehow, well, they get direct access. But even if our data is encrypted, our insecure application is pretty much, we're just saying to the hackers here, we've opened a door for you straight to our encrypted data. Because when we log in, when we go, say, for example, Windows 11, we log into Windows 11, we open up our files, it's unencrypted. and applications can have direct access to this. Think of Microsoft Word. If we log in with our username and password, we go into Active Directory, we get access to our folders, which is usually encrypted. While we're using it's unencrypted, and Microsoft Word gets to grab that data that's unsecured, and how we can type things into Microsoft Word. Because at the moment, it's temporarily unencrypted. Now, when we log off, it becomes encrypted again. It's not so easy for the hackers to be able to break into that because of the encryption. So insecure coding is actually a wonderful way for hackers to be able to get access to data that they shouldn't be able to get into if we have code or programs or applications that are not secure. This is a really important topic. Buffer overflow allows attackers and normal users, this is normal users too, it could be done by accident, to enter data into the application that it was not designed to handle. This could lead to a memory allocation issue. So what happens is with a buffer overflow attack, if we can somehow, if we create code that accepts a certain level of input, and we add extra data on top of that it's not supposed to handle, then we can cause some of that data to leak into other areas of the RAM. If that happens enough, the system could shut down. Even worse, if a hacker can predict how the data overflows into other parts of memory, if they can predict that, then they can inject their own code into that application, and that flows into other parts of memory. It keeps going on and on and on. That means, again, they're getting access to RAM, getting access to CPU through this way. It's very difficult to pull off, but it makes it a lot more possible for the skilled attackers. Another vulnerability is code injection. So if the code is not secure, then it means that hackers or attackers can add extra code to our code. So we've got our code, they add extra stuff to our code that they can run in the background. I'll do a live demonstration of this. It's pretty easy on a basic level. Lack of input validation. This is a kind of linked to buffer overflow and others. So basically what we're saying is that we're saying in our code, we'll accept anything. We don't care. And that's actually pretty bad. We want to validate our input. So validate means that if someone tries to add code, or sorry, adds a command or a number or a letter or something into our application, and we don't want them to, we want to be able to block that. We want to give them an error saying, no, I'm sorry, we can't accept that. Try again. Again, we'll demonstrate that later on. Hard-coded credentials. This is the definition of madness. Sometimes for programmers who are lazy, or for nefarious reasons, for bad reasons, or maybe just inexperience, they will add a username and a password, say like for a service account. Windows and has service accounts that enable Windows to perform some sort of tasks. And what the programmers they'll add the username and password, hard code those details into the code itself, and that's a terrible idea. What that means is if an attacker is somehow, they don't know about this, they can see this, then they can grab those hard-coded credentials and use it for themselves if they can discover that. Insecure update mechanism, that means that we're just not updating we're not patching our code or applications. Again, another bad idea. We need to be able to do that. Inadequate logging and monitoring. So if something does happen, that's an incident happens, which is like a bad thing that's happened to our system, we need to know about it really quickly. And we need to be able to organize it and see it, view it, get alerts, and then act on it ASAP. So some of the mitigation is things called SAST, DAST, SCA. And now the top three is about, these are sort of applications that are native. It depends on which operating system. I'll do an example on Kali Linux, which is an Ubuntu type of Linux, where I test the code. Okay, I'll actually test for vulnerabilities. Um, so, for example, the first one, SAST, which is a way for us to test our security that will analyze. Sorry, so SAST will analyze the application's source code. So the actual source code, it will analyze it so we don't have to go through it ourselves. We could look through the code by ourselves. And if it's only like 15 or 16 lines of code, so it's just a small script, we could do it ourselves. But if you're looking at 15,000, 21 million lines of code, we can't look through it visually. It just take us too long. And humans are error prone. But we can use SAST, which will analyze the code without executing it. So it's the raw code, the actual code itself. Again, we're going to do a demonstration on that. It not only helps with the security of our code, but actually can see errors as well, and it will tell us. Dast, on the other hand, actually evaluates the application as it runs, see what it does, and give us advice on whether it's happy, if the Dast system is happy with how it's viewed the code. If the code has vulnerabilities, it will tell us to say, look, this is not good. There's vulnerabilities here. That it'll tell us that one. And then finally, the SCA. So this is the SCA is a security testing method focused on identifying vulnerabilities in open source and third-party components used within applications. It scans the software's dependencies, okay, to detect known vulnerabilities, license issues, and outdated components. So the SCA goes out and tries to find the issues with the dependencies, and that's really hard to do if we don't have a tool like this. So we'll do a demonstration on that a little bit later on as well. Okay, now time for some demonstrations. So if you've viewed the lab guide on how to set up the lab in a previous video, then please fire up your Kali Linux machine. And I've already done a couple of these codes already. I've already written the codes. You will have instructions. There will be a lab guide that you can follow along. But I'm just going to do a demonstration. You can do this live right now if you want to follow along, or a little bit later. But basically, I'm going into a terminal, and you don't need any other tools. You don't need anything else for this one. The first lab that we're going to do is I'm actually going to show you a code that's actually insecure. It's not secure. But I'm only going to do this at a basic level. So I'm only going to run a basic script. In the wild, in real life, it's much more complicated than this. Okay, just letting you know, this is just a way for you to sort of like get to understand what's happening here. Okay, you might not ever do this in your professional career, but it's good to see in action and it's good to practice, even at a really basic fundamental level. So I'm just going to scroll up now. Actually, let me just, I'm going to see what I've got here already. And I've got a insecure script already up here, but I believe that it's, that I may have deleted the actual code itself before, but no problems. I'll be able to grab that code really quickly while we're live because I've got it here. So I'm going to do that now. So you can right click from the lab guide. What you need to do now is you need to go to sudo, very important, type sudo please, and then go to nano. So this is nano is is sort of like a like Notepad, word processing kind of app, but really basic. And the reason we use this is because most Linux operating systems have this all the time. You might have a command line interface. You won't have a graphical user interface, a GUI. So Nano is always available. So what we're going to do is we're going to call this insecure script. So that's the name of this. Oh, look, it's there already. Okay, that's good. So the script is there. That's great. So basically, all I'm doing is just echoing, saying, welcome to the insecure demo script. But then I'm going to ask the user to enter their name. And I'll read that name. And then I'll say, And by the way, you write the username, which is Callie. Callie's the username in this example. And what we'll do is we're going to display, yeah, we're going to list the home directory of that username. It's a really simple script. It's a bash script, so don't forget to put the shebang up there. And let's have a look at this in action. So we're just going to go Control X to jump out of that. The next step you need to do is you need to make this a executable. Very important. You need to make this, give it executable rights. You need to do sudo change mod or chmod -x, and that means that it's now executable. And that's the name of the script. Okay, great. We can run that now. Otherwise, it won't work. It will say, we'll give you some type of error. Now we run the script. So it's a ./in secure.script. Now the script will run. Okay. What I'm going to do is I'm just going to write Callie. And what this is doing, let's just move my head out of the way. It's showing us the list of our files and folders. This is what we want. Okay. I'm happy with this. I created this script for this purpose. Okay. It's going to clear to get a bit more, make it a little bit better. But it's not secure because I'm going to do this again, but I'm going to add some malicious code to this now. I'm going to inject some code. What I'm going to do is I'm going to put a semicolon, and this is the code I'm going to write this command touch, which is just a simple way of creating a file with nothing in it. And the file is going to be called text. Actually, I might say bad text file. Now you can insert all types of stuff. I'm just giving you a quick example here. I could, I could say go to direct use a command to go out to GitHub and go to a repository where I've got lots of evil and nasty things and download it and run it. I mean, that's how dangerous this is. Basically, what it's done now is so I've got Callie, it did its job, but it injected this command as well. The way to prove that is I just do a list now. So I'm going to see that bad text file was created. That's an example of an insecure code, and that's an example of injecting code into a script. Again, just to let you know, just so that you're aware, this is a very basic demonstration of this. Okay, it's not going to be that easy in the wild, but that's basically what we're doing here. So what do we do about it? What we can do is we can make a file that is secure. Okay, we're going to secure this in Lab 2, which you should all have. We're going to change the code so that it is secure, and we're going to test it out. Now, I believe that that's probably the one I deleted. So I'm going to go to sudo, and now, again, I'm going to create another file called secure scripts. So this is the secure script. Yep, and that's empty now. This is the one I deleted before. So I'm going to the lab guide. Okay. And I'm going to get some code or some script. So I'm going to copy that. In VirtualBox, you can paste selection, but I've added something different here. I've added, and you'll notice, this is the biggest issue with securing code. I've got to work harder, and I have to add extra lines to the script. I have to make it more complicated. That's the balance of cybersecurity in general. On the one hand, if I want security, on the other hand, everything has to be harder, and it has to be more difficult, more complicated. That's the balance. That's the challenge that we're facing in cybersecurity. Security coding, I've got to make this code more complicated. What I'm doing here is I'm doing an if-else statement. If username, pretty much is saying that if the username has is between small letters between A to Z, small letters. If it has capital letters A to Z, and if it has numbers and letters, we're good, no problems. But if we don't, then we are saying only alphanumeric characters are allowed. This is an example of data sanitization. Okay, so Control X, and that should give me yes. I'm going to say yes to that because I want to save this. I jump out. Let me just clear the screen. I then do a sudo chmod, which is making it executable, secure script. Now it's executable. I'm going to run it now. Script.sh. I'm going to write Kali. I just want to see that this works. It works, okay? And I don't see anything extra there. So we know it works, no problems, all good. Now let's try to inject some malicious code into this. I'm going to run this again. And this time I'm going to do the same thing as I did last time. And I'm going to write touch. I'm going to write naughty script this time. If I do that, it won't let me. Computer says no. So I've got, it says that it's not allowed. So I've secured my code, but you saw the trade-off there. In order for me to secure the code has to be more complicated, has to be longer. Now on a small script like that, you think, what's the deal? What's the big deal? But if you've got 1,000,000 lines of code, you will now have 1.5 million lines of code. Securing code takes work and it consumes resources. That's the trade-off. Okay, that's what cybersecurity is all about. All right, now, so that's how to secure it. The next lab, which is lab 3, I want to, before I run this, say the other code, the first one, the insecure. So we're going to work on, we're going to go back to the insecure code from now on, okay? And we're only going to work on those now. So what I want to do is I want to scan the code and the actual code itself before running and see if there are any issues. Now, I already know that I'm going to get some issues. It's mainly main errors. I just want to show you to show you what it actually looks like. Okay, it's not that, it might not be that realistic in the real world what I'm going to show you, but it's at least it gives you an idea of what's happening here. So if what you need to do is you need to download an application called Shell Check, and the way to do that in an Ubuntu/Kali Linux environment is type sudo apt update. And what that'll do, it'll go to the Kali Linux server. It'll download the latest package, the details, the metadata of the packages, not all the packages, just the metadata of them. And that should take a while. And then I'm going to install Shell Check, which is the app that we're going to use to do this SAST scanning. So sudo apt install Shell Check. Now I've already installed this. Okay, it will take you a little bit longer on your systems, but I've already installed this. Okay, and that's why it's saying that, look, you don't need to upgrade, you already have it. But on your systems, for the very first time, you'll get this. You'll get it downloaded, and it'll take a little bit of time. I'm just going to clear the screen, get a bit more space there. And now I'm going to run the actual scan on my insecure code. So I'm going to go, for some reason it works without sudo, but just out of habit, it's probably a good idea to do this. And I'll do that one, and now it'll give me error list. It's talking about something about mangle backslashes. It's actually not telling me that there's a security issue on this script, but in real life, when you're working out that, you'll get a lot of information. But this is a very useful tool because it's actually telling me some other things too. Like it's saying you should actually put a \r to make your code more efficient. So this is a good tool. So that's all there is for lab 3. Nice and easy. Okay. So now we're going to jump into lab 4. Now lab 4 is a little bit more complicated. This is a tougher one. I want to run this script. So what I've done is I've created the lab, which what we'll do is we're going to create a web server, okay? And we're going to run the web server. We're going to use a tool that when we, so this tool will actually scan the web server for the script and watch it run and actually see it, visualize it as it's running. Let's have a look at this. It might be a little bit confusing to look at this, but hopefully you will be able to see something interesting here. So this is lab 4, which is DAS, which stands for Dynamic Application Security Testing. And what we need is we need to download a tool called Nikto. So we've got a sudo apt install Nikto. Now, you might already have this on Kali Linux. It should be there, by the way. It should be there. In fact, if we go to the applications connector, if you like, and then if you go down to vulnerability analysis, it's going to be there. Notice vulnerability analysis, it will be there. Okay? But what we're going to do now is we will run this, clear the screen, and I'm going to quickly whip up a Python 3 application server, just something really, really quick and simple, because I just want to get this for everyone out there. Let me just double check. I've put Python, not Python. So it's a Python. So the server's running at the moment. Okay, so I'm just going to minimize that, put that on the side for a bit. I'm going to open up another terminal. Okay. Now I could do something like this, right click and split vertically, and that splits it. We might do that. That might be a better idea. So you can have two sides. So because I want to leave this running and I don't want to interfere with it, but I want to still do some code. Okay. So we'll just leave that there in the background. I'm going to go to Firefox and get that running. Actually, before I do that, I forgot the IP address. So if I go to IPA, and what's the IP address here? It is 192.168.14 or .1.254. I can enter that into Firefox, and because I've got that server running, that temporary Python script there, 192.168.1.12. I think that's right. Hang on. 145. And by the way, it's not secure, so we have to do without the secure code there. Let's just double check that. One second. Okay, so I've just noticed that I've put in the wrong command there. That should be localhost. So if we write localhost, it should work. That's right, but it keeps trying to get that secure. There we go. So now we've got a web server and it shows us all the files that we have. You notice that the secure and insecure scripts are there. All right, so what we're going to do is we're going to go back to on this side because by the way, you might have noticed that as the server's running, the quick Python server that we've got here we're actually seeing stuff that's happening in the background. So it's a bit of a log there. But what we want to do is we're going to use, and I don't know why, but it worked without sudo, but I'm going to put sudo because I'm just out of habit. Nikto, and this is the code. So we're going to use Nikto to find vulnerabilities in that script on the web server. It will run it and it will test it live. It's pretty amazing actually. Go to localhost in secure script sh, put the password in there, and it will see. You notice on the left hand side, and it's scanning. You can see a lot of work happening, and on the right hand side, it's going to give us information about the test. It'll tell us about vulnerabilities, or it'll do whatever it'll check a lot of different things there. The goal of this exercise is not to actually find the vulnerabilities, because I know it's just one little vulnerability there. But in larger applications and codes, especially that's run in a web server, you can just press no to these parts. There's lots of information. It says tested. There's a lot of stuff there. You can go to the links there to find out more information about this sort of thing. But we're not going to find much vulnerabilities because it's a script. There's not much going on here. But at least you know how to do this. Awesome. So so that's the end of lab 4. Now, if we go to lab 5, and by the way, I'm going to just Control C to shut down that web server because I don't want that running. And just to make sure that it's run down, you just go back here and refresh. It's gone. Okay. I'm going to collapse the subterminal, so I only have the one now. So I've learned a few different Linux command codes today as well. So with the lab 5 software composition analysis SCA, we want to test the dependencies. So if we're borrowing code or libraries from somewhere else, what if we're borrowing it from something it's a bad sort of library or script or something? We can test that. So now what I'll do is so this is a bit different. I'm going to copy another code. Now, let me just check something. So so the first code, so we're going to call this my script. So sudo nano my script dot, actually I might do this sh. I'm going to right click and paste the code. Okay. So basically it's just doing a system check. So this is the code. We're going to create another script that will depend on this script here. And then we can analyze it. Control X and then Y to save it. Okay. I believe we'll have to do a chmod as well. My script. Great. And now I'm going to create another script. I guess you can call it try to think of it. I will call it we will call the new one sudo nano scar. Not a great name, but scar lab. Okay, and it's all in the lab guide, by the way. And hopefully this works. I'm going to copy the new code, paste selection. They're a bit long here. Control X and then yes. And then I'm going to change mod to make it executable. Scar lab.sh. Okay, so that's good. Okay, and now All right. So what we want to do is we want to run this script to check. So I think this is the one we should be running. Just double checking. Yep, this is the SCAR lab. So if we do that, so what this is, so this, the second script, sorry, I've got it the other way around. The second script will analyze the first script, that first script, right? Let's have a look at that first one again. So my script. So we're going to analyze this one, okay? This is the script that is going to be analyzed, right? And the second one is the one that's doing the analyzing, okay? Hopefully that makes a bit of sense, yeah. Again, it's not the actual application of programming. I know that this is not as very useful, but what might be, you might find a need for it, but it's the idea, the concept, and it's a bit of hands-on too. It's good to get your hands onto scripting and coding, practice some Linux, practice some Bash scripting, Linux commands here and there, but also it help you solidify the knowledge. Okay, so hopefully that helped a bit. Now the final one is a bit of a challenging one as well. This is the buffer overflow. And what we need to do with this one is we're going to need something in C. We're going to write some C language. So we need to download a compiler, because C is not a scripting language, it's an actual programming language. So we're doing that, we're downloading that, creating the files. This lab, I was, it used to crash the whole system, but Linux is actually clever enough these days to be able to stop that happening now. It stops this buffer overflow attack. But let's have a look at this. I'm just going to wait for this to finish and then we'll see how that works. I'll put pause. Actually, I was going to pause, but it's looking good. Okay, so that looks like that's worked now. So we've got everything we need to do this. So the code will be in the lab guide as well. Just copy and paste. I don't want you to spend too much time on the actual coding because it's not a scripting or coding class, but it's kind of handy to learn anyway. All right, so I'm going to clear that, and I'm going to do sudo nano, and I'm going to create an application, an actual program. It's not a script. This is a code. Vulnerable, okay? Then I'm going to copy this code, copy, and paste. And then I'm going to exit and then save. Okay, so we've got that in C. So now we've created that. Now what we'll do is we'll need to compile it, this program. So we'll compile this. Vulnerable. Let's see. Oops. I got to get the typing right. fno stack. I know it's a bit weird. You can copy and paste this too, but stack. I'll probably make a mistake here. Yeah. So I'll need to copy and paste this because my typing skills is horrendous. Oh, maybe I might need to do sudo in front of that. No problems. There we go. It was just my typing skills there. So now I'm going to run the script. Hello world. Okay, everything's fine. Okay, great. No problem. So we're running okay. That's how it should work. And I know that it's not really a great example here, but I'm just showing you, this is the buffer overflow attack, by the way. And we're going to enter stuff it's not designed. So this application is not designed. Now, in the old days, this will completely crash the system, okay? But now Linux is clever enough to stop this, I hope. But if I disappear, you'll know what happens. So I'm going to, you know what? I'm just going to copy and paste the command. Copy, paste selection. There we go. And we've entered that. And yeah, it should have crashed the system, but Linux is actually clever enough to stop this. So that's a good thing. Sorry, you know what? I've made a little bit of an error here. My bad. Let me just check this. I thought I was expecting something else. Yeah, there we go. That's what I'm expecting. You notice that I've entered, so this is like A times 100, so it'll whack in a lot of A's at the same time. But guess what happened? Linux picked it up and it gave us a segmentation fault there. So it's picked up that buffer overflow. But there are hackers out there that are very clever, very smart, and can find ways that actually will perform a buffer overflow and destroy the system. Or if they can predict this error, then they can add extra code into it, which then can give them access to the system. But that's about it. That's the end of the session today. So we've done lab 1, 2, 3. You can have a break during the time, but we had the 6. So thank you very much for the lesson. Thank you for viewing this video and looking forward to seeing you into the next videos. Thank you. Have a great day.